Okay, we're gonna talk about something called sampling distributions and estimates. Sampling distributions and estimate. What does this mean? Okay, now first of all, let me give you a little two table. Remember, we have a sample and then we have population. Do you remember this? Okay. If we talk about a size, what do we use? Little n, and then we use capital N, right? And the mean, sample mean x bar, population mean mu. Okay. Standard deviation. Okay, what is the sample standard deviation? S, and this is sigma, and variance, that will be S squared, that will be sigma squared. What else? Oh, proportion. 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 We use letter P and P hat. P hat. And this is P. All right. So we do a quick review about this is the difference that we use letters to show those things for each, either a sample or a population. All those and all those, they have a name. This is called a statistic. Statistic. Okay. This is some measurement. What kind of a measurement? Whatever. For the sample, it's called a statistic. And for this, for population, we call this parameter. P-A-R-A, parameter. Okay. So these two are equivalent, or these two are parallel. Sample size, sample mean, sample standard deviation, sample variance, sample proportion, they're called sample statistic. And the population, we use different letters to show them, and each one of them is called a parameter, population parameter. So that's not hard. This is not the hardest thing to understand. Now the next one we want to know is, what is the sampling distribution, which is the sampling distribution of a statistic. For example, mean. The sample proportion, sample mean, sampling distribution of x bar. Now, let me tell you this. X. For example, we talk about the age. Okay, we talk about the age. That's age. Age of all school students for our school. Okay, all the students, their average age. I am looking for the mean. So I'm looking for mu. I don't know, right? And what I can find is x bar. Can you? Yes. If each time I take like a 50 students, can I get an x bar for this 50 students? Yes, you're gonna get a number, right? Because you ask each student, how old are you? Then you get all the numbers, so you average that. So when n equals 50, you get a 1 x bar. Okay, now put those 50 students back. Draw another sample of a 50 student. You get another x bar, do you? Do it again, and again. Do you get a lot of x bars? Okay, if I have 100 students in my class, I ask each of you to find 50 students at the school, get the average of their age, which is the x bar. Do I get 100 x bars? Right? Because I asked each of the students to give me a sample mean. All right, now I have all the x bars. If I repeat this again and again, if I ask you to do this like 5 times or 10 times, 100 times or whatever, I will have a lot of x bars, isn't it? Yes. What do you think about the distribution of the x bar? What do you think? Let's assume the student's age, okay? The age, it's somewhere between, I just made things up. Let's say it's a college student, 4-year college only. So the average maybe around 20, okay? And so here maybe the standard deviation maybe 1. I don't know, I just made this up. Okay, so that's this. What about x bar? The distribution of x bar. What do you think about the x bar? I get all the x bars. What do you think the mean of x bars? It should be also 20, right? But what about the standard deviation? Because remember, each time your x bar, it's already getting closer to the actual mean, to the mean. And each time it gets closer. So if you want to draw them, it's going to be like this. Sorry. It's going to be really focused or really close to the middle, right? It's going to be like this. It's going to be like this kind of distribution. Okay? So let's just forget about that. And this is x bar. So the mean here is also 20. But the standard okay, look at what I'm writing. Standard deviation of x bar. It's going to be a very small number. Guess what? It's going to be just 0.1. Very small. It makes sense, isn't it? Because we're not talking about the distribution of x. We talk about the distribution of x bar. That is called a sampling distribution. Okay, and not only for x bar, but also for standard deviation, for variance, for p hat, for all the different statistic, we can also to get the sampling distribution. I hope that makes sense to you. All right. Now, why we want to talk about this? Because most of the time, we don't really know this. We don't know we might not even know n. We don't know the population mean. We don't know the population standard deviation. We don't know the population variance and population proportion. What do we know is this. Okay. And we use this to estimate. We use the sample statistic to estimate the population parameter. Make sense? Okay, so that's what statisticians do, right? That's what we're going to learn. All right. Now, what we can tell based on I just explained to you, we see the distribution of the sample mean is also very close to a normal distribution, or the distribution of the sample means or proportions. They all turns to be approximate normal distribution because they're getting close to the real mean or the real proportion. And the sample proportion target the value of the population proportion in the sense that the mean of all the sample proportion p hat is equal to the population proportion p. The expected value of the sample proportion is equal to population proportion. What does that mean? That means if you do this, if you get the sampling distribution of p hat, then the mean of the distribution of p hat should be the same as like I said, should be the same as the population proportion. Also for mean, for x bar, the distribution, the sampling distribution of x bar, if you have that distribution, like I ask you to do this again, then the mean of this x bar should be very close or should be the same as the population mean. Okay, so if you do this a million times or billion times, then the mean of that is the same as that. The mean of this is the same as this. We call this unbiased estimator. Unbiased means right target on that, which means X bar sample mean is a unbiased estimator of a population mean. Sample proportion is a unbiased estimator of the population proportion. Did you notice that I didn't mention the standard deviation and the variance? Yeah, because they're biased estimator. It is also a good estimator, but it's biased. Okay, I will explain to you later. Now, first of all, let me give you this one example. Okay, we're going to repeat a process. You roll a die, this example. Okay. You roll a die 5 times and find the proportion of odd number. Proportion of odd numbers. What is odd number? 1, 3, 5, right? Because that's the die. Okay, 1, like that. Okay. Right. So what do we know about the behavior of all sample proportions that are generated at this process continue indefinitely? Just like I said, you do this million, billion, trillion, quadrillion, I don't know, many times. Okay, so if you roll a die 3 times, and then what is the proportion that you're going to get an odd number? 5 times, sorry, 5 times. Okay, find the proportion of odd numbers. If you roll this 5 times, the first time you might have even or odd, the second time you have even or odd, right? And the third time you have even odd, and okay, so how many possible odd numbers are there? If you roll this, what is the first time? And the proportion to get odd equals 0.5, right? Okay, and but actually if you roll this 5 times, number of odd numbers, I should say odd numbers. It could be none of them, could be 1, could be 2, could be 3, could be 4, could be all of 5 are odd numbers. So what is the probability? This is X. What is the probability of X? All even. So even. So is that a 0.5 to the 5th power? Or the sample proportion? Sorry, let's do the sample proportion. So that's 0. 0 over 5. And this is 1 over 5. So that's 0.2. 2 over 5, 0.4. And then 0.6, 0.8, and 1. Sample proportion of odd. Okay, so that's all the 6 possible values of your p hat, right? Okay, now if you repeat this again and again, and you count how many of them, what is the chance that you're going to get a 0? And that's 0.5 to the 5th power, isn't it? So that's 1/2 to the 5th power is 1 over, I believe it's 1 over 32. Okay, and what is the chance that you're going to get just roll 5 times, then you have only 1? That would be, what is the chance that you get this proportion? Do you know that? Proportion, again, count. 5, 1 of them is odd. So 1 odd, what is the chance you get a 1 odd and a 4 even? What is the probability of that? 1 out of 5. 1 out of 5. Combination or permutation, because we don't really care about a where, right? So it's this odd can occur at the first place, the second place, third place, and all the way fourth place and the fifth place. So there are five possibilities are there. Oh gosh, how do you do that? What is the probability that you roll a die 5 times, then you have only one odd? So that would be choose 1 out of 5, and it's going to be 1/2, which is the odd to the first, and then 1/2 to the fourth, right? 5 minus 1, and a C of that, which would be 5 times 1/2 to the fifth. So it's 5 times that, so that's going to be 5/32. And the same idea, if you forget, then it doesn't really matter, because the next one is going to be what is the chance, how many of them is going to be like this. So that's C5 2, and then 1/2 1, and a 2 here is 1/2 3. So that's a 5. Do you remember this? 2. We just learned this not long ago. And then 1/2 to the fifth, and then so 5/4, and then divide by that, so it's a 10. So it's a 10 times 1/32. So here's a 10/32. Okay, so this one is also 10/32. This one is a 5/32, and this is 1/32. If you add them up, the probability is just 1. Okay, so if you want to draw the probability distribution, it looks like this: 5, 10, 10, 5, and 1. So that's 0, 1, 2, 3, 4, 5, or 0, sorry, that should be 0.2, 0.4, 0.6, 0.8, and a 1, right? So this is your p hat. Did you see that? That's your p hat. And here is the probability distribution. All right, now we're going to do this again and again for many, many times. So what is the average of this? Or for this distribution, what is the mean of that? It's going to be, how do you find the mean? Expected value? That was a while ago, right? So the mean expected value is the mu of p hat, which is the same as a p. And what we're going to use is for each p hat times the probability of that p hat. I'm so sorry, there's so many p's, but this is the p hat value, and this is the probability of that p hat value. You multiply and then you add up. So you're going to use 0 times this, 0.02 times that, 0.04 times this, and 0.06 times that. So you do things like that. At the end, you will get the average, which is 0.5. Okay, so which agrees with that. If you roll this die randomly, then the chance to get an odd number is 1/2. Did you see here? We are talking about the average, or the mean of the sample proportion is the same as the population proportion. Basically, that's what it means. Yeah, I know it's kind of a confusing. Okay, but it give you the idea. It give you some idea that you know it. And what I ask you, basically, what I ask you to do is to do like to understand two things. One is the mean variance proportion, mean variance proportion, these three. Sample mean, sample variance, sample proportion is an unbiased estimator TOR of population mean, variance, proportion. You just need to know this. I think that's the most important thing. Let me just get different color. Sample mean is the unbiased estimator of the population mean, and the sample variance is the unbiased estimator of the population variance. Sample proportion is a unbiased estimator of the population proportion. I think as long as you know this, you're good. All right, now the next one is unbiased. Okay, sorry, this is unbiased. Biased means standard deviation. Sample standard deviation and median. Range is a biased estimator of population standard deviation median range. This is biased and this is unbiased. I think this is the most important concepts you need to learn in this session. Now I will give you one example to show this biased, and that you can understand what does a biased mean. Okay, let me think about one thing. Maybe median. Okay, median. Let's do median. All right. I give you some sample. I give you some numbers, okay? So I give you 2, 3, 5, 2, 3, 5, 7, 8. That's a very, very easy number. This is a population equals to 5. And what is the population median? 5. You agree? There are 5 numbers in the population and the median is 5. Okay, we keep this in mind. Now, I'm going to ask you to do n equals to 3, okay, to find the median. So how many possible samples are there? We can have a 2, 3, 5. I just treat them the same order because you can just permute them, and each one will have 6 permutation. And because every one has the same permutation, so I don't need to repeat again. So 2, 3, 5, 2, 3, 7, 2, 3, 8. Okay, and then 2, 5, 7, 2, 5, 8, 2, 7, 8. All right, and then I can go ahead and do 3, 2, 5 because I already have 2 here included, so I don't need to worry about that. I just keep going. Okay, so after I finish that, I finish all the one with 2, and then I do 3, 5, 7, 3, 5, 8, and 3, 7, 8, and then I have a 5, 7, 8. Okay, so of course you can permute them to get all of them, but I don't really need to. Now let's see what is the sample median in this case. The sample median is this a 3, 3, 3, 5, 5, 7, 5, 5, 7, 7. Now let's see what is the average of this. 3, 3, 3, 7, 7, 7, 5, 5, 5, 5. And what is the average of that? It's 5. So that's good. All right. So our sample median targeted at the population median. That's not a problem, but you're lucky because we have this. Now I'm giving you another example. You're going to see what I'm saying. Okay, I gave you 1, 2, 3, 4, 10. 1, 2, 5. Sorry, 1, 2, 5. 1, 2, 5. Let's see. Okay, 100 and 200. Doesn't matter. Okay, so all right, now let's see. What is the median in this case? It's 5, isn't it? Right, that's a population. Okay, n equals 5. Again, I'm going to choose a 3 random sample. So I'm going to have a 1, 2, 5. Again, I have this in order. So 1, 2, 100, and a 1, 2, 200, and a 1, 5, 100, and a 1, 5, 200, and a 1, 100, 200. Okay, I can keep going. I will do 2, 5, 100, 2, 5, 200, and then 2, 100, 200, and then 5, 100, 200. So I have all the possibilities. I list them. So what is the median? We have a 2, 2, 2, 5, 5, 100, 5, 5, 100, and a 100. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's add this up, then divide it by 10. So that's a 2, 2, 2. So that's a 6. And a 5, 5, 5, 5, that's a 20. So this is gone. This is gone. And there's a 300. So it's going to be 326. If I use this divided by 10, I get a 32.6. Oops. This is too far away from our population median. Did you see that? Your sample median is not a very good estimator for the population median. That means it's biased. Okay, so as long as you understand this, it's going to be much easier later, and you only need to remember this because we're going to focus on this a lot in the future, the unbiased estimator. So that's everything you need to know about this biased, unbiased. Okay.